Okay, so we are looking now at section 14.3, and this portion is the rate law, looking at the effect of concentration on rate. So one aspect of it is one can gain information about the rate of a reaction by seeing how the rate changes with changes in concentration. So if I change the concentration of one of the reactants, how does the overall reaction change? Like what are the components that, like, how does it get modified in this process? So here we have a collection of data, and we've got two starting materials. We've got ammonia, ammonium ions, and nitrite ions. And these, we have a variety of different experiments. So experiments 1 through 6, and we see different concentrations, and then we look at how is the rate changing as the different concentrations change. So you might look between experiment 1 and experiment 2. Notice how the starting amount of nitrite doesn't change, but the amount of ammonium ion does change. And so if you look at the rate doubles when the ammonium ion doubles. Okay, good to know. But then looking at another component where, let's say we take experiment 4 and 5. Experiment 4 and 5, the ammonium ion concentration is kept constant, but then the nitrite concentration is kept the same. Okay, and or is doubled. Sorry, nitrite is doubled, and so therefore you look at the rate when that portion, and you notice how the concentration doubles as well. So what that means is that each one of those components is what is called a first order type of rate. And so we have all these different concentrations. Let's look at another, or let me just kind of progress in the slides. So likewise, when we compare experiment 5 and 6 or 4 and 5, we see that when the nitrite doubles, the initial rate doubles. So what does that mean? How does that equate to something worth, oh, I guess I should probably go full slide. Sorry about that. And of course, it's going super slow. So what does that mean? So how does this compare? So what this means is that the rate is proportional to the concentration of the ammonium. The rate is proportional to the concentration of the nitrate. Therefore, the rate is proportional to the concentration of the ammonium times the concentration of the nitrate. So if we wanted to write this out, the rate is equal to K, or some constant, times the concentration of the two starting materials. So the starting materials have an impact, but it is at the what is called the first order, and we'll get to that a little bit later. But I just want to kind of put that in your brain as far as kind of a concept that we'll look at later on. So this equation is what's called the rate law, and K is the rate constant, and that would have to be calculated or known or given or something that you find experimentally to then utilize later on. So the rate law shows the relationship between the reaction rate and the concentration of the reactants. The exponents tell the order of the reaction with respect to each reactant. So since the rate law is this, so the rate is equal to K times the concentration of NH4 plus times the concentration of NO2 minus, that the reaction is first order in the concentration of ammonium ions and first order in the concentration of nitrite ions. Overall, for the whole reaction, it is a second order reaction because both the ammonium and the nitrite are first order, so they kind of add up together to determine the order of the overall reaction. And that's actually it. That's actually, we're gonna stop there because integrated rates is what we get into when we get into chapter 4. So and we'll get into a bit more when we look at data in class, but we're really looking at kind of being able to look at the data and look at, okay, from experiment 1 to 2, how are things changing? Is it a first order change or a second order change? And how does this allow us to then determine the rate law for that equation? So we'll get into that tomorrow in class, but we'll see you tomorrow.